We're on problem number 14. So I'm going to start this one in a weird place because I'm going to start with the ones where you don't have to do as much work and then kind of work backwards from there. It says 100 people were interviewed and classified according to their attitude towards small cars. So there were 100 total people. If you want to look at it separately, 60 of them had type A personality, 40 had type B, 37 said positive attitude, and so forth. So part C down here says more than half of the 100, which means 50. For each personality type, there were 50 that had a neutral. Well, that means both of those have to be 50, which is not correct. E says more than half of the 100, which would again be 50, have a type A personality and a positive attitude. How many have type A personality and positive?
25.
And that is not at least 50. So before we've really done much math, we can knock out C and D, or C and E. A says of the three attitude groups, which means we're doing it separately for each attitude, the group with the negative attitude has the highest proportion of type A. So to figure out, this is the proportion of type A separately for each positive, neutral, and negative. So how do I figure out my proportion of type A for positive?
The type divided.
What number divided by what number?
Type divided by 60.
So give me my specific numbers.
25 over 37.
So 25 over 37, and that ends up giving us 67.6%. Then I've done 11 over 20, which is 55%. And then 24 over 43, which is 55.8%. I think I rounded some of those. So, of the three attitude groups, negative had the highest proportion of type A. Is that true?
No.
No, because that one did. So this one switches to be the proportion of type B. Well, I can now do that really easily because there are only two of them. So it's the what of each one of those numbers. How do I figure out the proportion of type B? Instead of starting all over.
Change those to decimals and then do 1 minus.
Right, so it's opposite of those. So here I've got 32.4, 45, 44.2. So of the three attitude groups, the group with the neutral had the highest type B. Is that correct?
Yes.
And then just to double check, we're going to come down here. So the proportion that has a positive attitude towards small cars, is higher among people with type B than it is with type A. Proportion that has a positive attitude towards small cars is higher with type. So how would I do that one? So proportion that has a positive attitude among type B, how would I figure out that? So positive for type B, how do I figure that one?
12 over 37.
Now it's 12 over 40. It's switching them there as you're given. And then my positive for type A would be, and I didn't write those numbers down. I don't remember what those are exactly. This one's close. This one is closer to 50% than that one is, just looking at them. And so this one is not higher. Sorry, Andrew. And that one just tests a whole bunch of different things with, I don't love that problem because you have to do a lot of math in one multiple choice problem. You have to check all the different things.
Should we just, if it's like super long math, should we just skip it? Or?
It's not a bad idea if you know that you're going to have to do a bunch of math to save it for the end, so you're not wasting time. Number 5. A city is interested in building a waste management facility in a certain area. 100 randomly selected residents from this area were asked, do you support the city's decision to build a waste management facility in your area? Of the 100 residents, we had 54 say no, 4 say yes, and 42 had no opinion. A large sample Z confidence interval, so we're using 1 proportion Z interval, was constructed from these data to estimate the proportion of this area's residents who support building a waste management facility in their area. Which of the following statements is correct for this confidence interval? A says this confidence interval is valid because a sample of more than 30 was used. What is this part talking about?
Central limit.
And I want everyone to write what I'm about to write. What kind of problem? This problem is dealing with what?
Proportion.
Proportions. So what do I know about this?
It's not valid because it's for means.
And that's an issue that I'm seeing kind of across the board all semester across both my classes. Not like everybody, but I'm seeing that more often than I think I usually do. So that is definitely not the right one. Part B says the confidence interval is valid because each area resident was asked the same question. Well, is it true that each area resident was asked the same question?
No. Only 100 residents were interviewed.
But were they asked the same question?
Yes.
Yes. Does that make the entire thing valid just because I asked them all the same question?
No.
So I'm not going to mark that one out yet, but that's probably not what makes it valid. This confidence interval is valid because no conditions are required. Is that correct?
No.
Absolutely not. So mainly people got down to these two. Confidence interval is not valid because quantity of n times p hat is too small. The confidence interval is not valid because no opinion was included in the as a category for the question. If we are doing this, how many options are there going to be? 2. Well, how many options were there? 3. Now, it said we're finding it for the portion who support building a waste management facility, which means success is going to be they support. So what is failure going to be?
They don't support.
Anything else. So I can put these two together as not success, essentially. So this is one of those that it starts out as more than 2, but we can combine them to be 2. And a lot of people are going to accidentally pick that one because of that. But we actually reduce it to 2 here. And then now, so I'll go back to this one. This is checking to make sure that your sample size is large, or your number of successes, number of failures are large enough. For this problem, I mean, this one gives us easier than this, but technically, what is our n?
100.
Technically, how do I find p hat? But this is one where it actually gave us the number of successes already. And so n times p hat is supposed to be what?
It's greater than or equal to 10.
And it was not. So it's not valid. you're pretty much always going to have conditions for a problem for our class. And again, just like yesterday, if you have any side questions and you want to stop me at some point, that's fine. $29. The wording of this one, I think, is going to throw somebody for a loop. When performing a test of significance about a population mean, a test distribution instead of a normal distribution is often utilized. Which of the following is most appropriate explanation for this? In method, I'm going to do an example. One sample. We have a decision here of being Z or T with an arrow. If it is Z, what do we write as our arrow towards it?
And sigma is none.
If it is T, what do we write?
Since sigma is unknown.
And this is essentially what the problem is asking about. We used a T instead of a Z and Y. So we would rather use the parameter. But if we don't have the parameter, we have to do what?
Use T.
And if we don't have sigma, we have to use what directly?
S.
S. Well, what does that mean there's possibly going to be?
Error.
Error. So how do we account for error? We use T. Accounting for error is because we don't know if that's the correct answer, so it might be off by a little bit. The sample size is not large enough to assume the population distribution is normal. Well, the problem doesn't even say anything about that. That's not why we would use Z versus T. The sample does not follow a normal distribution. That's not true. Both of these follow a normal. There's an increase in the variability. I'm going to start at the bottom now. Population standard deviation is too large. Do we have anything set about how big the standard deviation can be? The sample standard deviation is unknown. Is that true or false? People are going to miss this piece because they're not thinking about it. This is saying we are using T instead. Why did we use T instead?
This population.
Because the population standard deviation is unknown. And that's not what that one says. C, now this beginning part, we don't talk about that as much in this class. But did we have to estimate sigma?
Mm-hmm.
Yes, by using S. Because there might be error, which means there might be an increase in the variability of the test statistic. And I think the wording of the question itself might make some people think they just don't know what's supposed to be there. $39. Alright, so 39 gives us a whole bunch of information. The weights of the population of adult male gray whales. Oh, I can't say that. So this whole first sentence is talking about adult male gray whales. It says they are approximately normal, which means we can do what? Use Z and yellow and all that stuff. It also says the mean is 18,000 and standard deviation is 24,000. And then the second sentence here starts talking about a different kind of whale. It also says those are normal. It says that mean is 30,000. It says that standard deviation is 6,000. And now it gives us this value right here. That 24,000, is that a gray whale or a humpback whale? So I know I'm going to put it with these values. And at the end, it's going to say this would have the same z-score as what over here. Now, I guess I'll work through the whole problem first. Can I find a z-score with this one? So what would I type in as my z-score?
24K minus 18K over 4K.
What is 24 minus 18?
6K.
What's 6 divided by 4?
1.5.
So I now have a z-score here. I want to now see what value that would be if it were a humpback whale with the same z-score. So now I don't know my x. I know everything else. So what's half of 6?
3K, so it's 9K.
So 3 plus 6, 9. So 9,000 equals x minus. So then I take this and do what with it?
Add it.
So 39,000. So just like a lot of these problems, and I want you to get this perspective because it's tools to use for the AP exam. If you didn't know to do all of that, you should be able to break this down really quick and narrow down the entire problem to 2 answer choices without doing any math. I know that I am comparing this number to the gray whales, right? How does this number compare to something in the gray whales?
It's above the mean.
It is definitely above the mean. Well, what is the mean for humpback whales?
30K.
So I know that what are my only 2 possible answer choices?
D and E.
Does that make sense? So I understand that it's got to be bigger than the mean. There are only 2 answer choices that were bigger than the mean there. Most problems on the AP exam, you can think through it like that and narrow it down to 2 or 3 answer choices without doing any math. If it's a workout problem. Number 25. The table shows the height in inches and the arm span in inches for 10 randomly selected high school students. Which of the following significant tests should be used to determine whether a linear relationship exists between height and arm span, provided that the assumptions of a test are met? I'm going to be more concerned with what we would be looking for in our wrong answers than what the correct answer is here. How many variables are we recording here?
2.
2. Are they categorical or quantitative?
Quantitative.
Quantitative. So I have 2 quantitative variables. How many samples did I take? I only did 1 sample and asked that 1 sample 2 questions, right? So what can I definitely already mark out?
A and B.
It is definitely not a 2 sample. Now, the wording of this should be an easy answer because there's something really specific in the wording that's like, okay, there's only 1 answer choice here. What's the wording in this question that gives you the answer?
Linear relationship.
What's my only one that tests the linear relationship?
T-test for slope regression line.
But I want to talk about what it would look like for these 2. So if it is a chi-square goodness of fit test, what would my data look like?
I would be comparing to like percentages of a previous.
What's a different way to say that?
It'd be in proportion.
Not necessarily. Like what would it physically look like?
One-way table or
Kind of like a one-way table. So it's different categories of one variable, which is essentially, I would think of it as a one-way table. So it'd be something like blue, yellow, red, with different numbers for each one. And so those are categories. We said these are quantitative. What would it look like with a chi-square test of independence? If I'm testing independence, how many variables do I have? 2. What kind of variables are they? Categorical or quantitative? Okay, go past that. What would visually my data look like? It wouldn't look like this. It would specifically be a two-way table. And to do a two-way table, it's categorical data. Now, this problem is set up to look like a different type of problem, which was not actually even one of the answer choices. If there were no question right here at all whatsoever, this is kind of set up to make it actually be a what? What do I know about 65 and 67?
They're the different lengths and height
Of what?
of the student.
So it would be like this, which is kind of setting it up to make it look like what? And I'm surprised they didn't do that as an answer choice because that's kind of how they set it up to look.
so that would be
Only because what it asks for is the linear relationship. Like that's, if there were no wording right here, it would have been a match choice. Or it could have been a match pair. $37. This problem you actually can solve out completely. This problem you actually can answer without ever doing any math, or you can kind of do a mix in between. So Dan, a trainer at Popular Gym, was interested in comparing level of fitness of students attending a nearby college, a community college, and those attending a four-year college in town. He selected a random sample of 320 students from the community college. 320 from the community college. They had a mean and standard deviation of 95 and 10. And then he also did a sample of 320 from the four-year college, whose mean and standard deviation were 92 and 13. He then conducted a two-sided t-test and got this test statistic value. So it gave me all the numbers with the two ends, the sample size, or the sample sizes, the means, and the standard deviation of each one. But it also gave me what that would give me, so I didn't really need to do any of that math. Which of the following is an appropriate conclusion from this study? So the means themselves are 3 apart. Is that enough to say that the two different means are significantly different? No, you got to think about it like, even if it's GPA, if two different things had a GPA of a difference of 3, is that enough to say they're significantly different. There's a lot more involved than just how different they are. So that is not correct. We're testing to see if one of the means is higher. If the second group has a bigger standard deviation, does that mean the means are higher?
No.
Just standard deviation alone means nothing about mean. C says the same thing but opposite. Because the second group had a larger one, the mean of the first group is significantly larger. Standard deviation alone tells you nothing about mean. So now we're down to D and E with no math. One of them says p-value is less than alpha, one of them says p-value is greater than alpha. I have all of my information to be able to find my p-value, and I'm actually going to do that in a second, but I don't really need to. Everything after the comma is exactly written the same. The mean of the fitness scores for the two groups are statistically significant. When do we decide that something is statistically significant?
P-value is less than alpha.
Well, both of them say, yes, statistically significant. One of them says the p-value is less, and one of them says p-value is greater. Which one of those is correct to say statistically significant? So I can get this entire answer without ever actually doing any math. Or I could have done the math all the way through and gotten the same answer. Just for practice here, because it's a good problem to do it. Yeah. I'm going to go ahead and work this one all the way out from the very beginning, too. $90.
5.
And what? And then
93, 13.
Alright, so if I were going to do this with my equation, and
Actually, yeah, the mean, yeah, it's 92, 92.
This is
that's
two.
correct, yeah.
if I were testing the difference here, well, let's just do it on our calculator, because it's a whole lot easier that way. I want everybody to have calculators out, because I'm just going to run through really quick. Oh, man. Purposely did not shut this, so it should still work. Should. And now that AP Stat is almost over, I finally got software to actually be able to do this on my computer. All right, so where do I go to run a test in my calculator? Stat tests. So we get a screen that looks something like this. What is this one? It's definitely, how many samples do I have? 2. Am I running a test or an interval? Test. So I have to decide between 3 and 4. It's 4 because I'm not given sigmas for both of them. So I'm given this screen. My X bar 1 is 95 and 10. 95, 10, 320. And then 92, 13, and 320. And then what am I, which? Not equal to, because it said what?
Two-sided.
It said a two-sided test. We never pull if we have the option, so we calculate it. And it gives us a p-value. So the test statistic 3.27 is the exact same one that it told us it was going to be. So we didn't need to do that part, but we just did it practice. And then our p-value is 0.0011. So I could have known that this is the correct answer because it is less than 0.05. And either one of those methods to get to the answer would have been correct. Some people just by habit would have, and some people would have started here and run a test statistic, second distribution, figure out what the area is, and gone from there.
Which test did you use for that?
I did stat test 4, 2 sample t test.
Two tests.
All right, number 40. I'm thinking people didn't read this. People that missed it didn't read it. 5 estimators for a parameter are being evaluated. The true value of the parameter is 0. So it should look like the true value of the parameter is 0, which means the whole thing should be what? Centered on 0. So which of the graphs are definitely not centered at 0?
C, D,
Definitely not D and E. C, maybe not as obvious, but still doesn't look centered on 0. So A and B both look centered on 0. This one's kind of weird as far as what to write. But now I have 2 options. What is different about these 2?
One is
The
more
width or how much it's spread. Well, which would I rather have, a bigger width or a smaller width?
Smaller.
So our answer is,
B.
and I'm thinking that people just didn't think about having it centered on 0 when they were doing this one. At 26. Some descriptive statistics for a set of test scores are shown above. For this test, a certain student has a standardized score of z equals negative 1.2. What score did this student receive on the test? What do I use to find a z-score?
mean standard deviation. An individual.
So, I guess I'll start from the value. I am solving for my value. What is the mean? Divided by and then I'm just doing the math there, so I'm doing negative 1.2 times 221.9 and then adding 1045.7 and you end up getting this as your answer. Now I want to talk about a lot more than just that for this problem though. Very, very obvious here. You should be able to narrow this down to 3 possible answer choices without doing any work. What does it mean that the z is negative 1.2?
That the
It's below the mean.
That it's below the mean. Well, how many answer choices are below the mean?
3.
So you should definitely mark out D and E at that point without doing any math. And if it's only 1.2 below and one standard deviation is 221, that should pretty much mark out A too without doing any math. Now, the thing that I think some people might have messed up on is this might have possibly confused someone. So,
you want us to write this?
yeah, this is a major differentiation concept thing that occurs throughout. If I'm comparing one individual, what is my equation for z equals? If I have a sample, which means I'm comparing the mean of that sample to my population, I alter this slightly, and it's what now?
X minus X bar.
Instead of an individual, I'm going to have a, what am I going to take from the sample? And if it's for an entire sample, what does this portion look like? And now a lot of you would do this by habit when you're in a problem without like realizing it looks like this. Technically, this is using the same equation, but if you only have one of them, then that is the mean. And if you only have one of them, then you'd technically be dividing it by what? 1, which doesn't change anything. So this portion right here, when we use S there instead, is the standard error of the mean. And that's what that would have been.
The entire thing, or just the S part of S over square root n?
S over square root n.
Okay.
This right here would give you 31.4. And if somebody was overthinking it, they might have accidentally used that here instead. And I could see where that would mess you up. But it's just a good point to talk about that. Yes.
So for that question, I just did the mean plus the standard deviation multiplied by the z-score.
Yeah.
Would I get points off because I didn't do it the way you did it?
No.
Because mathematically it's the same.
Yeah, that's what I'm saying. You went through these steps. You just, instead of looking through the equation, you just thought through it. Same thing. And even if that were a free response problem, that would still be absolutely fine. All right, 15. And actually, once we've covered the whole class, like we have now, there are usually more than one way to solve those problems. So in a study of weights of athletes, the player weights of a random sample of baseball players and independent random sample of hockey players were compared. The output shown are the results of the test. It is saying that we are testing baseball mean is less than the mean of the hockey.
Islam, could you show like what the skews on a box plot like represents and like the actual curve, like putting it into like how we would normally see the skews?
Like that you're talking about? Is that
Yeah.
Okay, we're gonna do one in just a second, and then if that one we don't cover it enough, then I'll go back and do it. But yes, we're gonna do one. So which of the following conclusions can be drawn? So of all of this, what is gonna be the most influential part of making our decision for the entire test? Like all of this, what's the one thing I actually use to decide my decision?
The mean?
After I've done all of this.
The p-value.
And what is the p-value?
0.076.
So really, out of all that, that's what I needed. So I'm gonna look at my answer choices here. I've got different levels that I'm comparing it to. So if my p-value is 0.076, I can look down here and see I'm either comparing it to an alpha of 0.05 or I'm comparing it to an alpha of 0.10. Here, I know that this is what this.
Greater or not less than.
This one. 0.076 is,
Less than.
and then this one is, the way I say it, not less than. So, with 0.05, is it significant or not significant?
Not significant.
and with 0.10, it is, right? So I'm gonna look here and kind of cheat my way through these. If it says is not, I should be looking at which one? 0.05. These three say is, which means I should be looking at which one? So I can knock out two answers at that point because those don't match up with what I said over there. So this one says the mean weight of baseball players is not significantly lower. Okay, I haven't looked at that yet. I'm trying to think of what that is.
It does say it's a 95% confidence.
Oh, we can do that. I don't have to, but that works. That might confuse some people. I mean, you're right, and yes, you could go through it that way, but I think some people might get confused by that. So the mean weight of baseball players is not significantly lower. I did not do this in the last one. Trying to think about the way I explained it to them. Baseball lower than hockey. Baseball higher than different. Okay, that's where it is. You're right with what you're saying, but I can do it this way and never have to avoid. I can avoid it as well. So this one says we're testing baseball players lower than hockey. This one says we're testing baseball players higher than hockey. This one says baseball players different than. Well, which one did we test? And so I can avoid everything just by the wording and understand that that's the correct answer. Oh, I marked out. I should have marked out that one. I'm gonna mark out that one. Alright, 11. I think this is a very easy problem because it gives you more than it needs to give you for this problem, and more than it typically gives you for this type of problem. And this is one like you're asking about. All right, so to start it off the way he was asking, looking at the histogram itself, where would you say the data is mostly? On the left side. In each section of a box plot is a percent, which is what percent?
25.
So if I have a whole lot in one space, is that going to be wide or narrow? Narrow, because I've got, here means I have 25% in, to compare it, I have the same amount of data covering all of this area as I do in this tiny little space. So this means I've shoved a whole lot in here. So this would show that because there's a whole lot on the left side width should be a lot smaller. Which means this one, the right side width, should definitely be a lot bigger. Now, I look at this kind of problem, a lot of times, maybe it's because I don't read well, I look at answer choices first a lot of the times to see what I have to work with. Especially on a problem like this, because I'm going to look at what's the same, so there's no reason to look at it. So what's the same with all those?
They all have an outlier, maybe some.
They all have an outlier and the dot's at the same place.
Yeah.
So there's no reason for me to look at that. What else is the same?
They all have a skew.
What else? Like more specific, like very obviously.
They all start at the same place.
They all start at the same spot.
They all have the same
They all have the same
They all have the same
minimum and maximum.
minimum, maximum, and Q1, I think. Right? So that only leaves me with a couple things to look at, and it's made my life a whole lot easier because that's all I'm going to look at. So what's one of the obvious things that's very different about them?
Quartile 3.
Quartile 3, what else? Median. So let's start at median just because it's easy. There are 26 of them, which means the median should be where I have what? Which means I should have how many? 13 on each side, right? Well, this one not only does it give you the values, but it writes them down for you. This is why I think this is too easy. So we have 6 at this point, we have 10, we have 16. So 13 on each side should be somewhere in that bar, which is between 20 and 30. So this one, my median is between 20 and 30. Median between 20 and 30. This one is not. This one is. This one is not. So I've knocked out these two. Another thing that I would look at is where this is. And this problem gave you more than you needed because it's trying to mess people up with that. This right here, they did not need to do for you. You could do that yourself. This number is the what?
The point where anything higher than that is a outlier.
I'm just going to call it the cutoff. Now, where should my horizontal line go to if I know I have an outlier?
The number below the outlier.
And this part I want you to write. Does it go to this number? It goes to the last actual data value that's what?
Below.
That's below that. We're not an outlier, same thing. And that's why they gave you this information, is to basically try to make people think that the line should go to there. So what is our last data value? We know it's below what? Our last data value is below what? That's not an outlier.
70.
Below 70. So this one went too far, too far, too far. So our only option left is D. And I could have gone through all those and done the breakdown and found exactly where the Q1, Q3, and all that is, but we just picked 2 things to go with, and that was enough to break it down. $20. Automobile brake pads are either metallic or non-metallic. An experiment is to be conducted to determine whether the stopping distance is the same for both types of brake pads. In previous studies, it was determined that car size is associated with stopping distance, but car type is not associated with stopping distance. So I'm going to write more than I need to. What is the response variable that we are measuring here?
Distance.
For my explanatory variable, I'm going to go ahead and write it separately as, so I have a generic name and specifics breakdown. What's my generic name?
Brake pads.
No. Like words like explanatory response. My treatments can be broken down into 2 things.
Factors and levels.
Factors and levels. So factors are my generic. So how many generic things, what is my generic thing that I'm testing? How many levels do I have that I'm testing?
2.
Which are?
Metallic, non-metallic.
And then it talks about these 2 other things. It talks about car size and car type. And it talks about their relationship with With what? With what of these?
The response.
The response. So one of them is associated with our response, which means it could possibly create what?
A lurking.
It could be a lurking variable that could cause confounding. If they impact the what? You just told me.
The response.
So what's this problem? What's this whole problem asking about?
There.
So we block for that.
So is blocking like a statistics term, or is just
Yes, it is a statistics term, and I'm going to show you how this would be drawn out, and you'll remember what I'm talking about. So the answer here is what?
By blocking car size?
We're blocking on car size because we block by something that directly impacts the response variable. So this is a randomized block design, which I'm going to start to draw out for you in a second, so that you'll remember what it is I'm talking about. So we start with our population over here, which is, I guess, cars with brake pads, cars. Yeah, cars. We have a certain number of them. So if we want to block, then I do what directly for my population? And this one, what were my different things I split on? What was it? Which were, yes, size, which were what, small?
Small, medium, large, I think.
Or something like that. So then now I have them broken down for each one. And so now for each one of these, I do what?
A car type. Which would be.
So I have to do what to do that? And then I would split this from here into how many?
3.
What am I assigning them to?
The car types.
Do we care anything about car types? So we don't even put it in here at all. Yeah. Which I'll do the same thing here and here. And then this is where at the end, I would do my results this way. So I could see how did the brake pads work with small cars, how do they work with medium cars, how do they work with large cars. So I could see this is what I'm testing. But this is what this problem is asking about right here, which is blocking. Now questions on anything about that problem? I was reading this one last class and I forgot about part of the problem, so I get why people miss this one. Alright, so a group of students have 60 houseflies in a large container and they need to assign 20 to each of 3 different groups. They can capture them one at a time when they fly in the chamber and they want to figure out the most likely result in the 3 comparable groups. So I want to make sure, if I want comparable groups, I want to make sure that they are randomized and so that they're not biased in any way. So label the first 20 flies caught as group A. Is that a good idea or a bad idea?
Bad idea.
Because something about these are the same, the fact that they are the first 20, whether that's a good thing or a bad thing, all of group A has something in similar, and that's bad. Group B, write letters A, B, and C on separate slips of paper, randomly pick one of the slips of paper, and assign the first 20 flies caught to that group. Better or worse than A?
Better, but not very good.
Slightly better just because I don't know which one gets which group, but I'm still doing the first 20 flies, so that's still bad.
And is it the same piece of paper? It's different this one.
It's just worded funny. It's that instead of the first flies definitely being A, I don't know which group the first 20 caught is. C, when each fly is caught, roll a die. So we're doing it by each fly. If the die shows an even number, it's A. If it shows an odd number, it's B. Where could if the problem stopped there, what could my issue be?
There could be more than 20.
So then it continues, when 20 flies have been labeled A and 20 have been labeled B, then the remaining get labeled C. Is that better or worse than B?
Better.
Is this one good?
No.
No.
Why?
Because it has a problem with C.
Yeah, all the flies from C could be like the slowest flies.
So even though A and B are doing better, C is still going to be similar in some way. So yeah, I'm better than A and B, but I'm still not good. Skip to E. When each fly is caught, roll a die. If the die shows a 1 or a 2, it's A. A 3 or 4, it's B. 5 or 6, it's C. We just talked about this. Is that good?
No.
Why?
Because you can end up with 1 in 20.
And then D says, place each fly in its own numbered container in the order that it was caught. Write the numbers 1 to 60 on slips of paper. Put the slips in a jar. Mix them well. Pick 20 numbers out. Assign the flies in the containers with those numbers to group A. The next 20 get B. The next 20 get C. Is that good or bad?
It's good,
That's pretty much the definition of what we usually write when we are doing random assignment.
but it says pick 20 numbers out of the jar. It doesn't say randomly.
But you've already
Randomized.
randomized initially. Yeah, I mean, you're right. It would be better if it said randomly there. But of those choices, it's definitely the best one.
Okay.
Yes, if you were writing a written one as like a free response, I would want you to say randomization in there. Oh, it said mix them well. I guess that's what it's trying to say. And I think C was where I wasn't reading my last class about that last part. 31.
What should we write for number 28?
You could write why you eliminated some.
Yeah, I would talk about like why you're eliminating, not like why things are bad. Number 31, candy company claims that 10% of its candies are blue. A random sample of 200 of these candies is taken, and 16 are to be found to be blue. Which of the following tests would be the most appropriate for establishing whether the candy company needs to change its claim? More than I would need to do. Let's just talk through this problem. Random sample is good. What is this? What is 200?
And
What am I using this to find?
the proportion or the percent, I guess.
So, what's my, other than N, what's the next thing to write? Alright, my success could be blue. My number of successes is,
16.
and I'm using this to find my,
Proportion of success.
symbol. Yes. What's my symbol? What am I going to do with these two numbers?
P. N times P. Or it was P hat.
Yeah. And this is all extra. You wouldn't really need to do all this to do the problem. And then, so what would this be?
Why is it that you're using the 100?
What?
Why is it that you're using 100 and not 200?
Because I'm not looking at the problem. What's my null hypothesis?
HO is equal to 20.
X.
Well,
What's here?
P
Oh, right.
is equal to 0.4.
That's my 10%. Again, all of this, you didn't really need to solve this problem, but it's a good problem to talk through. Looking at my answer choices, what did I definitely not do there?
Mean.
I definitely didn't do mean. What else? Looking at my answer choices.
2 sample.
I didn't do anything with 2 sample. We talked about chi-square already. If it's not chi-square goodness of fit, I would have a what?
True.
And that's definitely not what we have here. In order to have match pairs, how many variables would I have? So this should be a really straightforward answer of what you're doing there. Kind of surprised only 2/3 of the classes got this one right.
Is association the same thing as independence or
Homogeneity.
homogeneity?
But I don't like that they use that.
Would they normally do something like that?
So when you write out your, there's one of the hypotheses says independent, and the other one says, I'm trying to think of the wording of it. It's like, it doesn't say the word association, but it basically does.
Okay.
If you were looking at it in front of you, it would make more sense. Number 1. What? I'll get a second. Lynn is planning to fly from New York to Los Angeles and will take the Airtight Airlines flight that leaves at 8 a.m. The website she used to make her reservation states the probability that her flight will arrive in Los Angeles on time is 0.70. Of the following, which is the most reasonable explanation of how that probability could have been estimated? If I tell you I have a coin, you know that the probability that it's going to land on tails is 0.5, right? Why do you know that?
Possible outcomes.
And so what if I tell you I have a die in my pocket and you don't know how many sides it is, and I keep rolling it and just telling you what the answer is? How could we figure out what the proportion of something is? Like if I roll a die,
Divide the whatever you have by how many your sample size would be.
and so I would have to do that process, what? A whole bunch of times, right? So I'm repeating the same thing over and over to get that probability. That makes sense. So that's all this problem is asking about, but it's just a strange way because we don't usually think about it like this. So to get my 0.70, my first answer choice is an extended weather forecast for the flight showed a 30% chance of bad weather, which means there's a 70% chance that it's on time. Is that the only thing that we're accounting for here? No. Bad weather could still mean they fly. There could be other things that hold it back. B, by making assumptions about how airplanes work and factoring in all of those assumptions into an equation to arrive at the probability. I mean, maybe better, but it has nothing to do with, like, this could be out of Alaska, out of Hawaii. Those are going to be very different, and it doesn't even talk about that. So C, D, and E, this one says of all flights arriving from California. This one says all flights in the United States. This one says all previous days of that particular flight that have been scheduled. Which one of those is a better option of the thing that has been repeated to get that idea? And that's just not a way that we usually see it written. So some people kind of miss that because they're just not thinking about it. We're repeating the same thing over and over to obtain that probability. What is the definition of the word census?
everyone is asked the question. Each individual in the population is asked the question.
It includes all individuals in the population. Now, this one talks about a proportion of for all of them, but in order for census, we're just trying to see can we obtain all the individuals or not. So I don't even care about what my success is. So for A, this doesn't matter. And what is my success? What am I deeming as success in A?
Having lights and being licensed.
So I don't care about this. I just care about obtaining all my individuals. So my individuals in this one is licensed bicycles on the university campus. So I'm basically saying I don't care about anything that's what I'm obtaining other than what the individuals.
And the more part.
So would I be able to obtain all licensed? Would it be reasonable to obtain all licensed bicycles on a university campus?
No.
Why?
Or would it be easy or difficult?
If they're licensed, we've got them written down somewhere, right? Students in a high school, would that be something obtainable?
Mhm.
That's probably written down record somewhere, hopefully. Registered students enrolled in a college,
Uh-huh.
again written down somewhere. Single family dwellings in a small town.
Mhm.
Maybe not as easy as those, but still records are kept. Fish in Lake Michigan.
No.
That was probably a little bit hard.
Would you have to, so like, let's say you gave all those options, but one of them like wasn't licensed or registered. So like,
Yes,
say the
so it
options
is.
were A through D.
Yes, if it did not say licensed, or it did not say, register in C would be a little, probably could technically get by with without registered. But if it just said bicycles on a university campus, that without the word licensed would really knock it to the different answer. 6. And I'm surprised this one wasn't higher just because people don't pay attention to the question. But I'm more concerned with wrong answers for this problem than the right answer. A fair coin is to be flipped 5 times. The first 4 flips land heads up. What is the probability of heads on the next flip of this coin? What does this problem absolutely not care about at all?
The first 4.
The first 4 flips. So we are only concerned with when I flip it this one time, what's the probability that lands heads up? So my answer is what? B. So it's a very straightforward question if you're reading it. Now, I want to talk about the wrong answers and what it's set up to look like. Not thinking necessarily about the problem, but just looking at the setup of this. I'm in part D. I am doing some result 4 times in a row, and now I'm getting a different result. So, kind of like this scenario, but not the way it's written, this would be like doing what 4 times? What do you think this is set up to be? Well, this one is talking about what the problem is, which is getting what?
The first one would be like if you were to get tails 4 times in a row.
So this one is my probability of failing the first 4, and then all of a sudden having my first success. What is that called? Until my first success.
Oh, geometric.
So this one is set up to look like geometric, even though the wording of the problem is a little bit different than that. What is C set up to look like?
That
There's only one equation that looks like this at the beginning.
binomial.
And that equation is n choose x Then my probability of success times number of successes, probability of failures times number of failures, and that one's set up to look like that. A is set up to be, I got what I wanted. E is set up to be, I didn't get what I wanted. And so that kind of problem could easily be asked with the exact same answer choices and slightly different wording and be a different answer choice.
Wait, you said A was I got.
A was just like, A was just say probably that it was head, or it saying you got heads.
I wanna write that down or take a picture. Or should we just keep it?
Yeah.
What was the percent who got this correct?
Versus 6. 73. Sometimes the ones that are so easy like that, people just overthink them.
Wait, 73 was that got correct or did?
They got it correct.
Wait, 76 people got that one wrong?
73% got it correct.
Oh, okay.
All right, number 36. Now, this one, I'm just going to look at and never do any math and get to the right answer, and then we'll go back and do it. Again, like I said, I always glance at the answer choices so that I'm not dealing with more than I need to. What's very obvious about those answer choices?
Everything not under those.
It's definitely an interval. What about all this part?
This is identical.
What do I know about all those? They're the same, so don't look at it. These numbers should trigger something.
90%.
If it is 90%, I use what? If it is, what's my other one? Well, just scanning through the problem really quick, what is this one?
90.
So I can immediately knock out those because they're trying to do it with a 95% instead. So now I'm down to 3 answer choices. Well, but all of them have 250 and 100. I have 2 different sample sizes up there, that's right. Now let me read through the problem first. Independent random samples of 100 luxury cars and 250 non-luxury cars are examined to see if they have bumper stickers. I'm figuring out a success rate for each one. There's 125 success for the non-luxury and 30 success of the 100 luxury. So those are just my numbers to use. So in this one, these numbers are pulled out to the front, which means it's applied to both. So what did I actually do to get those numbers? That I'm using the same numbers for both of them.
Combined.
I combined them. When?
2 sample proportion.
2 sample proportion, but only if it's a what? I claim that they're the same, which means I am doing a.
Test.
But what are all of these? Intervals. So should I pool? No. So here I pooled to get that. What are those? The same thing, just written as fractions instead. So this is my answer without having to do any math. Now I could look here, 125 out of 250 is going to give me that 0.5. And then the 30 out of 100 is going to give me that 0.3. So I could have just started from the beginning and worked out the math and done it right and got the same answer. But this one I could kind of work through without doing any.
I can see the.
When me saying noise, I didn't know if it was the color I used for me saying that. Can't remember how much farther I went with the other class. I'll tell them some problems. Okay, we did this one. This might be the last one. When I am dealing with, yeah, it's up here. What do I know about each of these?
25%.
25%. Do I know how many are there? No. A botanist is studying the petal length measured in millimeters of two specific lilies. The box plots above illustrate the distribution of petal lengths from two samples of equal size. Is that important? The same N means I can directly say there are, this is 25, this is more than 25%. So there are more here than there are here. If this statement were not there, I could not say there are more here than there are here. I could just say higher percent as opposed to more. Does that make sense? There will be problems that do not include this and throw you off because of that on purpose. So this is extremely, extremely important. But now that it has that, it makes it easier on us. So interquartile ranges are the same for both samples. How do I see what is representative of the interquartile range? The whole what? The box. Well, is the box the same for both of them? No, obviously not. That's not the right answer. The range is represented the entire thing. The range for one is bigger than the other one. Is that true? No, those are the exact same. So now we're looking at specifics here. So greater than 70. Sorry, my line's not very straight. What percent is greater than 70 for B?
Above 25.
What percent is above 70 for A?
Less than 25.
So there are more for A than B. Is that true? No. Now I'm switching to 40 and above. So what percent is here for A?
50 plus.
What percent is here for B?
Less than 50.
So this one says there are more for B than A. Is that true?
No.
And then E says we're going less than 30. What percent is here? What percent is here?
50 or above 50.
So there are more for B than there are for A. Is that true? So you're just having to look at them individually to figure that part out.
What do you write for this one? So it's kind of just looking at it.
Yeah. Can we just write like